Welcome to section 7.3, where we're going to look at long division of numbers, long division of polynomials, and something called synthetic division. So let's look way back to numbers. Supposing I wanted to take 347 divided by 2. We took 2, put it on the outside, so the bottom is on the outside. We've got this kind of a bracket line thing. And then I've got my number, 347. And then we thought to ourselves, how many times did 2 go into 3? Well, it went in there one time. And so 2 times 1 is 2. And then we subtracted. 3 minus 2 is 1. And then we brought down the next number. And then we started again. 2 goes into 14. How many times? And that was 7. So 2 times 7 is 14. We subtracted. We got 0. We then brought down the last number, which was the 7. And how many times does 2 go into 7? Well, it goes 3 times. So 2 times 3 is 6, 7 minus 6 is 1, and that's my remainder. So 347 divided by 2 equals 173 plus 1. Now when we move over to polynomials, it works almost the same way. Now the only thing that's kind of different is, okay, here's my outside part, and here is the inside part. What's different is any terms that are missing must be filled in by zeros. What do I mean by missing? Well, the highest power is a 3, then a 2. I should see an x to the 1 next, and it's missing. So when you write the polynomial, anything missing that term would be filled in with a 0. All right, so the focus is on the x. What times x would give me this 5x cubed? Well, it would be a 5x squared. X squared times x is the x cubed, and 5 times 1 is 5. And then we subtract 5 minus 5, 0. But what about the 2? Well, that's the second term. 5x squared times this minus 2 is a minus 10x squared. Now I've got the minus and it's circled, so I remember to keep going out there. 5 minus 5, 0. Minus 18 minus a minus 10. All right, so it's a minus, so it's really minus 18 plus 10, which would be a minus 8x squared. And then I bring down this other piece. All right, I play the game again. What times x would give me a minus 8x squared? Well, that's going to be a minus 8x. All right, so minus 8x times x, a minus 8x squared. A minus 8x times this minus 2 is a plus 16x, and I'm subtracting. So minus 8 minus a minus 8, that's 0. 0 minus 16 is a minus 16x. And then I bring down the last piece, this minus 54. So what times x again gives me a minus 16x? Well, that has to be a minus 16. So we subtract minus 16 minus a minus 16, that's 0. Minus 16 times that minus 2 is a plus 32. And a minus 54 minus a positive 32 is really minus 54 minus 32, which is a minus 86. That's the remainder. All right, so the top part is the 5x squared minus 8x minus 16. My remainder is minus 86 over the thing that was on the bottom. All right, let's try another one. Let's see. All right, so here in question 2, the outside is x plus 1. The underneath part, well, they wrote it in a weird way, so I'm going to rewrite it where the powers go down. Let's see, 4, 3, 2, 1, and a number, so nothing is missing. Okay. So what times x gives me the 3x to the 4th? Well, 3x cubed. All right, and then the 3x cubed times the 1 is my 3x cubed. So let's subtract. 3 minus 3, 0. 5 minus 3 is a 2. We subtract, okay. I bring down the next term, play the game again. What times x gives me a 2x cubed? Well, a 2x squared. And a 2x squared times the 1 is a 2x squared, and we subtract. 2 minus 2, 0. 6 minus 2 is 4. And then I bring down the 17x. All right, what times x gives me a 4x squared? Well, that's going to be a 4x. And a 4x times 1, 4x. And we subtract. 17 minus 4 is 13x. And I bring down the last piece. What times x is 13x? Well, that's 13. And so 13 times 1 is 13. We subtract, and I get a remainder of 0. So my answer is only this top part. Okay, so just remember that you are subtracting. It helps me to circle it so I remember it's important and I keep going out there to take care of the minus. All right, question 3. All right, let's see. Outside part, 2x plus 4. Inside part, well, it's all jumbled up. Got a 4x to the 4th. I don't see a cube term, so that's a 0. I do see an x squared, that's there. I don't see an x, that's also missing. But I do see the number on the end, the minus 24. All right, so what times 2x would give me a 4x to the 4th? Well, that's got to be a 2x cubed. And the 2x cubed times the 4 would be a plus 8x cubed. So let's subtract. 4 minus 4, 0. 0 minus 8, I get a negative 8. And then I'm going to bring down this minus 10x squared. What times 2x is a minus 8x cubed? All right, well, I need a negative 4, and I need an x squared. Okay, so a minus 4x squared times that 4 is a minus 16x squared, and we are subtracting. So minus 8 minus a minus 8, 0. minus 10 minus a minus 16. That's a minus 10 plus 16, which is a 6x squared. I bring down the 0x. All right, what times 2x gives me a 6x squared? Well, that's a 3x. And the 3x times the 4 would be a plus 12. And we subtract. All right, 6 minus 6, 0. 0 minus 12. A minus 12x, and I bring down my last number. All right, so let's see, 2x times something to give me a minus 12x looks like a minus 6. And a minus 6 times the 4 is a minus 24. We subtract minus 12 minus a minus 12, 0. Minus 24 minus a minus 24, that's also 0. And so we get no remainder. And so the answer is just the top piece. All right, question 7. Let's see, it says use long division again. We have a large item on the outside. I've got all this stuff for the top. Let's see, anything missing? 4, 3, 2, 1 number. Nope, nothing is missing. All right, my focus is on the 5x squared. What times that one number gives me this lead part? Well, that would be a 3x squared. And so 3x squared times each one of those pieces gives me this 15x to the 4th, 3x cubed, and a 15x squared. Now we have a lot to subtract. 15 minus 15, 0. 3 minus 3, 0. 20 minus 15, and I get a 5. Now I bring down all the rest of this stuff. Again, what times the 5x squared gives me the lead part? And that's just a 1. And so now 1 times each of those pieces. All right, so 5 minus 5, 0. 2 minus 1 is 1. 8 minus 5 is 3. And that thing there is the remainder. All right, so I take my remainder that goes over the piece on the outside, and the top part goes out in the front. All right, and then we will come to a new form, which is called synthetic division. Now, synthetic division is very fast. It works great when we're dividing polynomials. But it has a severe drawback, and that is this synthetic division only works. So only works. It only works if the bottom part looks like x plus or minus a number. If it's any other thing on the bottom, synthetic division will not work. Again, not. So synthetic division would not work on this problem because I've got a squared. And synthetic only works if I've got x plus or minus a number. If I go all the way back to question 3, synthetic will not work here as well because there's a number in front of the x. It only works if it's just plain old x plus or minus a number. Okay, so it will work on this problem, question 5. So what do you do? I'm mainly focused on just the coefficients. Okay, on the bottom I've got x plus 7, and if I set that equal to 0, I get minus 7. Okay, that's the number that goes here in the front. Now, in traditional synthetic division, no one puts this stuff on the top. I put it there personally just to remind myself, do I have any missing numbers? Let's see, 3x squared, 27x, and a 4. Nothing is missing. The way the game is played, the first number comes straight down. Okay, so I got the 3. I then take the minus 7 and it gets multiplied by the 3, and I put the result right there, which is the minus 21. I'm going to add these numbers. Somewhat confusing because on all the previous ones we subtracted. Now we are adding. 27 add a minus 21 is 6. And then I play the game again. I go minus 7 times 6. That's a minus 42. And I put that there. I add again. 4 add a minus 42 is a minus 38, and that's the remainder. That's the remainder. So the remainder always goes over the thing that was on the bottom. These first two are the coefficients, and they are the coefficients of variables that are 1 degree less than the top. So you see I had an x squared there, so this is the coefficient for x. This piece is the number, and that's what we have there. And if you did the same problem by long division, you would get exactly the same thing. All right, what about here in question 6? Let's see. I got x plus 1, that's the bottom. So x plus 1 equals 0. So that's a minus 1 when I move it. That's what's out there in the front. All right, let's see. Got a minus 5. Let's see, and it's on a x4, so I expect to see 4, 3, 2, 1, and the number on the end. Let's see, minus 5 for the 4. Oh no, I don't have any x3. It's missing, so that gets filled in by a 0. I do have a squared, that's minus 6, got a minus 9, and a 7. So the minus 5 comes down. I've got minus 1 times minus 5, that's a plus 5. 0 add 5, 5. And I go again. Minus 1 times 5, minus 5. Add and get minus 11. Minus 1 times minus 11, I get 11. Minus 9, add 11, I get 2. And one more time, minus 1 times 2 is a minus 2. I add, and that's the remainder. So let's see. This was a 4, so now this must be the cube, the squared, the x, and the number. And the remainder goes over the item that was on the bottom. All right, and again, you could do it by long division, and you would get exactly the same result. All right, let's see. Use the remainder theorem to determine if C is a zero of the polynomial. Well, what does that mean? Well, let's see. If I have a zero of the polynomial, then that means that C equals 7. So that says that C minus 7 is a factor. And so what that means is if it's a factor, that means it would divide cleanly into this big item. And if it divides cleanly, that means I would get a remainder of 0. Okay, so C being 7 means C minus 7 is a factor. C being minus 3 says C plus 3 is a factor. All right, so let's take a look. All right, so the C number goes directly there because the bottom part would be 7. I grab all my coefficients, nothing is missing. 4, 3, 2, 1, nothing is missing. All right, so let's see. Bring down the 5, 7 times 5, 35, add, and I get 41. 7 times 41 is 287. And 287 add a minus 15 is 272. 7 times 272 is 1904. Add that to 14 and I get 1918. And multiply that by 7 and I get a giant number. And if I add that to minus 66, I'm going to get a big number. I am not going to get 0. So C minus 7 is not a factor. Okay, what about C being minus 3? Let's see. That would say C plus 3 is a factor, or it would divide in cleanly. Let's see, minus 3 times the 5 that came down, minus 15. Minus 15, add 6, minus 9. All right, minus 3 times minus 9 is a 27. 27 minus 15 is a 12. Minus 3 times 12 minus 36. Minus 36 and 14 is minus 22. Minus 3 and a minus 22 is a positive 66. And if I add, I do get a remainder of 0. So yes, C plus 3 is a factor.